So the first thing we're going to do on page 10 in your notes is find the volume and the surface area of this right rectangular prism. When we've been given the name of the prism, it tells us the shape of the base. Again, we're on page 10. We're on page 10. I'm curious if you guys could, though, flip back to page 9 and tell me what is the general volume formula for any prism, not just a right rectangular prism, but the volume formula for any prism. What is that volume formula?
Base times height.
Yep, area of the base times the height. But it is a capital B, that means base. Area of the base.
Why is it H capital?
The H is not capital. The B is capital because it is specifically the area of the base. H is not area. H is just the height. This is the height of the prism. That being said, if the H is capital, it doesn't mean anything different than if the H is lowercase. But if the B is capital, it does mean something different than if the B is lowercase. All right, so we have our right rectangular prism. We need area of the base times the height. I know my base is a rectangle because it told me that right here, and I can also see it in the image. Thank you. Appreciate it.
I'm not doing
Okay, I still have to give it to you. How do you find the area of a rectangle? How do you find the area of a rectangle? How do you find the area of a rectangle? Length times width, yes. So the area of the base is going to be length times width, and then multiplied by the height. So on this right rectangular prism, what is the length? 20 is my length, yes.
How do you tell the difference between the length and the width? Because
There is no difference, and it doesn't matter which you call which.
oh,
There is no difference between those two. But we're going with 20 for our length here. If 20 is the length, then what is the width? 9. Width is 9. And the height would be what? The height would be 8. I'm actually really glad that you brought that up about how do you tell the difference between the length and the width, because technically on a right rectangular prism, there's no difference between the length, the width, and the height. Because the height is the distance between the bases. And this is a right rectangular prism, and all the lateral faces are also rectangles. So I could look at any one of these faces as my base. Yep. What do we get when we multiply 20 by 9 by 8? How much? 1,440. What units should we put with that? Centimeters cubed, yes.
Are they all going to be big numbers or no?
Not necessarily. It depends on the numbers that you're multiplying together. All right, now we have surface area. What was the general formula for a surface area for any prism? What was our surface area formula for any prism? 2 plus pH?
No, 2B.
2b, capital B, because it means area of the base, plus what? Plus pH, capital P, lowercase h. This B means the same thing as before. It means area of the base. You guys told me just a moment ago that we find the area of the base how? On this one? Length times width. So we're going to do 20 times 9 because that's what we decided were our length and our width here. We get 180, yes. So the area of the base is 180 centimeters squared. We're going to need that number for our surface area. Surface area equals 2 times 180 plus, does anybody remember what the capital P stands for? Perimeter. Perimeter of what? Of the base of the prism, yes. This is the perimeter of the base. So the base would be down here. So I'm going to go in and draw in these sides that we can't see that are being covered up. Perimeter of the base, I need to add all the sides of the base. Well, how big are all the sides of the base? Yep, 20 plus 9. And then the back side back here would be another what? Another 20. And this side over here would be another 9. So we would do 20 plus 9 plus 20 plus 9. And what would that give us? 58. 58 centimeters for our perimeter. So I'd put 58 here in the place of P. And then the H is the height of the prism. What was the height of our prism again? 8. All right, so now we're going to multiply these together. The first one that we're going to multiply is the 2 times 180. What do we get when we do 2 times 180? We get 360 plus, what is 58 times 8? 464, and then we add those two together to get our total surface area. What is the total surface area? 824, and that would be centimeters squared. All right. Just like with a cylinder on my surface area formula, the 2B is the area of the two bases. The perimeter times the height is my lateral area, the area around my two bases that connects my two bases. You guys ready to look at a prism that does not have a rectangular base? All right, let's go look at number 3 then. Number 3, once again, we want volume and surface area. We want volume and surface area for the right equilateral triangular prism. What do we know about equilateral triangles? Yes, all the sides are congruent. What about the angles? They're also congruent. So all the sides are congruent and all the angles are congruent. It says an equilateral triangular prism. So what shape are the bases? Triangles. So this is a base here. And this is a base back here. Those are my equilateral triangles. Because it said it's equilateral, all 3 sides on the triangle are going to be the same size. So every side of the triangle is how big? 5 inches. All right. And we said all the angles are the same size too. How am I going to find the size of the angles? The 3 angles in a triangle have to add up to 180. We have how many equal-sized angles here? 3 equal-sized angles. So I take 180, I divide it into 3 equal-sized parts. That's what division does for me. It cuts it into equal-sized pieces. What is 180 divided by 3? 60. So each of my angles here is 60 degrees. All right. What's our volume formula for a prism again? Yep, area of the base times the height. So we need to find the area of this base. And what's the shape of the base again? Triangle. So it's not length times width anymore, because that's not how you find the area of a triangle. We had 2 formulas that we learned back in Module 11A for the area of a triangle. There's one that you guys knew from before, 1/2 base times height. And then there was a new one that we learned, the 1/2 AB times the sine of angle C. Let's figure out which one of those we're going to use here. To use 1/2 base times height, I have to know one side of the triangle that we're going to call the base. And then I need from the vertex down to that side, I need the height of the triangle that goes from a vertex down to the side. Do I have that on this triangle? No. I do not have something that goes from the vertex down to the side and makes a right angle with my side. To use this area formula, the 1/2 AB times sine of angle C, I need 2 sides of the triangle, not just one. And then I need the angle in between those 2 sides. Do I have that information about this triangle? Yes. So we're going to have to do the 1/2 AB times the sine of angle C to find the area of the base. In for A and B are my sides. How big are the sides that we know of on this triangle? 5 and 5. So we're going to put 5 in for A and 5 in for B because both sides have a length of 5. Times the sine of the angle in between them. How big is the angle in between my 2 sides? 60 degrees. All right, now we need to grab our calculators. We're going to do 1/2 times 5 times 5 times the sine of 60 degrees. What do we get? 10.825. That would be inches. That would actually be inches squared because that's area. Remember, that's area of our base. We're going to take that number now and we're going to substitute it into our volume formula. Area of the base, 10.825 times the lowercase h. Remember when we said the lowercase h was the height of the prism? The height of the prism will be the same thing as the length of a lateral edge. A lateral edge connects the 2 bases together. So I'm looking for an edge here that connects my 2 triangles together. Do you guys see an edge like that that connects the 2 triangle bases? How big is it? 9. Right here is the height of my prism. So we're going to put 9 inches in for the height. So I have 10.825 times 9. What do we get when we do 10.825 times 9?
97.427.
97 point, I got 425.
Well, I got it.
427.
You got 427? It's possible that I wrote it down wrong too.
No, it's because I just multiplied the full decimal.
Ah, you took the whole decimal. See, I took the rounded one.
Oh.
Yeah, yes. 97 point, I'm going to write 425 since that matches the actual work that I have up here, but if you had 427, there's nothing wrong with that. That's absolutely fine. It's perfectly acceptable to use the exact area of the base and multiply that by the height. And that would be inches cubed. All right. Surface area now. What was our surface area formula again? 2 times area of the base plus what? Perimeter times the height. All right, we already have the area of the base. We don't have to go find that again. So 2 times 10.825. What do we get when we do just that much? 2 times 10.825. I didn't get 20.825. I got 21.65, yeah. 21.65 plus the perimeter of the base times the height of the prism. The perimeter of the base, I have to add all the sides of the base. How big are all the sides of the base? 5. And how many sides do we have? 3. So I'm going to do number of sides times the length of each side. 3 sides, each side has a length of 5. So we have a perimeter of 15 inches. So we're going to put 15 in for P times the height of the prism. What was the height of the prism again? 9. What do we get when we do 15 times 9? 135. So then we add 21.65 and 135 together, and what do we get? 156.65, and that would be inches squared. All right, so when we have a base that is not a rectangle, we've added another layer of complexity here. We have to identify what are the bases. Those are the 2 identical faces that never touch each other. 2 identical faces that never touch each other will be our bases. Once we've identified what the shape of the base is, we have to figure out how do we find the area of that shape. And we did that in 11A. That's why we did that part first, so that we would know how to find the area for these different shapes. All right, let's look at number 4. We are going to find volume and surface area of, what is this shape? Yes, it's a right regular hexagonal prism. What does that word regular mean? Yes, all the sides are congruent. All the sides are congruent, and all the angles are congruent. Regular means both. All the sides are congruent and all the angles are congruent, just like equilateral meant both. We go looking for the shape where I have 2 of them and they never touch. That would be right here. We have 6 sides, so that's a hexagon. And up here we have that exact same hexagon mirrored, and they never touch each other. How big are each of the sides of that hexagon? 6 centimeters, yes. Every side is 6 centimeters. What is the height of this prism? 10 centimeters is the height of the prism, yes. It goes right here. All right. Volume formula. Volume is equal to the area of the base times the height of the prism. And we said our base is what shape? It's a hexagon. Let's see who remembers how to find the area of a regular hexagon. Did we have a formula just for hexagons? No. We had a formula for our regular polygons. A regular hexagon would be a type of regular polygon. What was our area formula for regular polygons? Yes, 1/2 apothem times perimeter. So I'm going to need the perimeter, and I'm going to need the apothem. And that perimeter is perimeter of the base. So we're going to do big capital P. I'm going to do this up above because I've got a little bit of room there. How many sides do we have? 6 sides. How big is each side? 6. So number of sides times the length of each side would give me 6 times 6, which would be what? 36. 36 centimeters for my perimeter. I still don't know what I'm putting in for the apothem yet, but I at least have the perimeter. So let's talk about that apothem. I'm going to redraw. Oh, no, I can do it up here. It is not 3. That's a good guess, though. 3 is going to be an important number here. So we're going to go from the center of the hexagon to the side. That's my apothem. I'm also going to draw in a radius. A radius goes from the center to a corner of the hexagon. And now I've made this triangle right here. I'm going to redraw just that triangle down below so that I can mark it up a whole lot more. So I have this, and this, and this. The blue line is my radius. The black line is the apothem. The red is part of the side of that hexagon. It's not the whole side. The apothem does what to that side? Cuts it in half. We said that side was 6, so how big would half of that be? 3. So this would be 3 centimeters right here. I'm going to need my angle, which means I need the measure of the central angle. How do you find the measure of a central angle? Yes, measure of the central angle is 360 divided by the number of sides. We had 6 sides, so my central angle would be 60 degrees, but what does the apothem do to that? Cuts it in half, so this angle right here is only 30 degrees. This is the angle that we're going to stand at. We need to label up our sides. Which of those sides, radius, apothem, or the 3 centimeters down at the bottom, is the hypotenuse? Radius is the hypotenuse. Based on standing up here at this 30-degree angle, which side is the opposite side? The 3 centimeters is my opposite side. And so that means the apothem is which side? The adjacent side. We want the adjacent side. We want the apothem, and we know the opposite side. Which trig function, when you think about SOHCAHTOA, are we going to use when we want the apothem and we have the adjacent? Or sorry, we want the apothem and we have the opposite. Tangent. We're going to use the tangent function. So I have tangent of 30 degrees is equal to my opposite side, which is 3, over the apothem. What do I need to do if I'm going to solve that for the apothem? Yep, multiply both sides by the bottom, by the apothem. If you do it to one side, don't forget to do it to the other side. So over on the right, the apothem that I'm multiplying by and the denominator cancel each other out. Over on the left, I have apothem times the tangent of 30 degrees equals 3. What do I need to do now to get the apothem by itself? Divide it. What are we going to divide by? Tangent of 30 degrees, yes. It's the apothem that I want to get alone, so the thing next to the apothem is what I have to divide by. All right, I need you guys to grab your calculators now. We need to do 3 divided by the tangent of 30 degrees. 3 divided by the tangent of 30 degrees.
The apothem would be 5.196.
5.196, yes. So we're going to use this right here to find the area of our base. We would have 1/2 times 5.196 times our perimeter of 36. What do we get when we multiply 1/2 times 5.196 times 36? You said 0.528. Thank you. I just couldn't hear. Centimeters squared. All of that worked for the area of the base, but now we have the area of the base, so we can easily find our volume formula now, or volume of the prism, not volume formula. We have our volume formula. All right, so for volume, we take the area of the base, which is 93.528, and we multiply that by the height of the prism. What did we say the height of the prism was again? 10. So we multiply 93.528 by 10, and we get what? (935.28), and that would be centimeters cubed. All right. We have all the pieces that we need for surface area, so let's go ahead and find that. Surface area is 2 times the area of the base plus the perimeter of the base times the height of the prism. So we do 2 times, what was the area of our base again? 93.528. Let's go ahead and pop just that much into our calculators right now. What is 2 times 93.528? 187.5. 0.056 plus the perimeter of the base. What was the perimeter of the base? 36 times 10, the height of the prism. You're absolutely correct. So 36 times 10 would give us what? 360. So then we add 187.056 to 360. What do we get? 547.056, and that would be centimeters squared. Nicely done. There is one final problem that I would like to do with you guys. Number 5. There is a slight typo on number 5 that we're going to need to fix before we get into solving it. So let's look at number 5, and then I'll tell you what the typo is so that we can fix that, and then we will go from there. It says a cube has been constructed with, here's where our typo is. That should not be 87.375, that should be 84.375. $84.375. All right, cubic centimeters of cardboard. I want to stop there for just a second. If we talk about what something has been constructed out of, this has been made with cardboard, right? This has been constructed with cardboard. If I told you how much cardboard it took to build this box, am I telling you about the volume or the surface area? Surface area. So right here where they're telling us how much cardboard was used for this, they're telling us the surface area has been constructed with this much cardboard. That is our surface area. How many cubic centimeters of space does the cube contain? If I'm talking about how much this box could contain, what am I telling you about, or what am I asking for? The volume. So here it wants me to find the volume. They gave me the surface area. They want me to find the volume. Before we start doing any work here, I have one more question, and that is about this word cube. What does it mean by cube? How is a cube different from this box that I keep holding up?
It's shaped as a square, but 3D.
Yes, it's a shape of a square, but 3D, like this right here. So every single face is a square, which means all of the edges are the same size. You're absolutely correct. All the edges are congruent. So I'm going to draw a cube over here. So I'm going to start with a square. I'm going to bring it back like this and down. I'm only so good at these, but it's good enough. You guys understand that's supposed to be a cube, right?
Yep.
All the edges are the same, correct?
Yes.
Do we know how big they are?
No.
No. So if I don't know how big something is, what could I call it? X. So that means my length is X, my width is X, and my height is X. They gave us surface area, so I'm going to start with the surface area formula. Surface area equals 2 times the area of the base plus the perimeter of the base times the height. The area of the base. What shape is the base again?
Square.
A square. How do you find the area of a square? Close. Very, very close. It's side squared. Oh, I thought I heard something in addition to that. I am so sorry. That'd be my hearing. Side squared. And how big are the sides? X. So my base area is x squared. All right, we also need the perimeter of the base if we're going to talk about the surface area formula. My base is what shape again? A square. What do we know about all four sides of the square? They're congruent. So if one of my sides is x, what would it be if I go all the way around? 4x. I have four sides that are all the same, so I'd add x plus x plus x plus x to get my perimeter.
Can you do like exponent 4? Like,
No, that would be 4, or sorry, x to the power of 4 would have a very different meaning. That's x times x times x times x. This is 4x is x plus x plus x plus x. So yes, the difference there being multiplication versus addition. With an area of our base, it's squared because we do length times width, x times x. All right. So now we're going to need our surface area. This 84.375 is going to go in the place of surface area. 84.375 equals 2 times the area of the base, which was x squared, plus the perimeter that we said was 4x, times the height of the prism. What is the height of the prism? Just x. The height is x. The height is x, the length is x, and the width is x. All right, so I have 84.375 equals 2 times x squared would just be 2x squared, plus, now I have 4x times x. Be careful here. 4x times x is not 5x. That would be 4x plus x. Yes, this is going to be 4x squared. Whenever you multiply variables together, the exponent changes. When you add variables together, the coefficient, the big number out in front, gets bigger. But when we multiply variables, it's the exponent that changes. All right. Are these two, 2x squared and 4x squared, are those like terms that I can combine? If I have 2x squareds and then another 4x squareds, how many x squareds do I have altogether? 6x squared, as we add those coefficients together. 6x squared. I want to get x all by itself, because if I can get x all by itself, then I know the length, the width, and the height, and I can find the volume. I'm going to need to get rid of this exponent of 2, and I'm going to need to get rid of this 6. Which one do I have to get rid of first? The 6. We always have to undo any multiplication or division before we get rid of any exponents. So we're going to divide both sides by 6. What do we get when we divide both sides by 6 here? You said how much? 14.062. Was there one more number after that? 5. Let's go ahead and write them all down since it ends at 4 decimals. 14.0625 is equal to x squared. And then we square root it, yes. If you do it to one side, you got to do it to the other side. Over on the right, the squared and the square root cancel. What is the square root of 14.0625? How much? Oh, yeah, you did a different root. 3 point what? 3.75. 3.75 is equal to x. So that is the length, the width, and the height of the cube. So when I go to find the volume, volume is area of the base times the height of the cube. We said the area of this base was x squared, right? And the height is just x. What happens if you do x squared times x? We get 1x to what power? X, yep, no, you were right the first time. X to the third power. That is the same as x cubed. And we just figured out that x is 3.75. So we have 3.75 cubed, 3.75 to the third power, which would be what? 52.734. And that would be centimeters cubed. Very nicely done, ladies and gentlemen. You have Prism homework that is due tomorrow. Worksheet that we picked up in class yesterday. If you did not get a copy of it yesterday, you forgot to pick it up, or you've misplaced yours, or you weren't here, you can grab an extra copy down here, this very bottom paper in the red organizer.